Hello, in this video I'm going through the Set 3 Express end of year 2022 exam. I will only go through question 6 to 8 in this video, and I'm going to skip question 9 because it is quite straightforward and most of you got it right. Okay, for question 6, it is about temperature and in particular thermometers. So if you want to have a thermometer that will give you interval that is regular on the scale, you actually require the temperature and that thermometric property to be linearly related. Some of you gave the answer as directly proportional. Unfortunately, we cannot accept that because it is impossible for any conductor to have zero resistance. A conductor with zero resistance is called superconductor. We are yet to be able to produce them in room temperature. So because of that, unfortunately, directly proportional would be an overstatement. Then there are some of you who gave this term linearly proportional. We have checked with the mathematics teacher, and they also didn't use this term linearly proportional. It is not used in mathematics, and so is physics. But with a search on Google, we can see that some articles do use this term linearly proportional. Unfortunately, we really do not know how Cambridge mark, right? They didn't publish their marking scheme. So because of that, and since end of year exam by its nature is to check how much you have absorbed from our lessons and how much you have retained from it. So since we didn't use this term linearly proportional in our lesson, we would not accept that in this exam, and it is all we are doing this out of good intention because we want to discourage you from using it. We are very sure that Cambridge will mark you as correct if you use the term linearly related, and at the right context, if you use directly proportional, we know that you will be marked correct. But we are not so sure whether they will accept linearly proportional. So it is with this good intention, we want you to take up good habits. That's why we couldn't give you the credit for in this end of year exam. Yeah, so do not argue with your teachers. The three of us has agreed that linearly proportional, we will not give you the mark. Okay. Okay, for part B is the calculation. There are still some of you who refuse to use the method that is used by us. So in this case, if you use other method, you got it wrong, maybe you won't get the working mark. So just let me take this opportunity to go through this question if you got it wrong. So if you are given 2 points, temperature, resistance, the corresponding points, you can actually sketch out this very easy graph, right? In the question, they already tell you that when the temperature is 20, you are going to get 100 ohm, and if the temperature is 130, you are going to get 143 ohm. And we are assuming that the relationship is a linear one, meaning that it is going to be a straight line graph. And when you have a straight line graph, you can say that the gradient between AB, the yellow line, and the gradient between AC, the orange line, these two gradient has to be the same. So if you go and equate the two of them, you should be able to find the temperature without problem. So this method can be applied to all your thermometer, including thermocouple. So this is a method that can solve it all. So I strongly encourage you to actually learn how to use this. For question 7, 7A, most of you get it correct, very good. Most of you have remembered that kinetic model of matter is about matter. So for those students who actually start your answer with particles are moving constantly and randomly, we will not give you the mark because this is a model for matter, not for particles. Okay. For part B, actually it is quite straightforward. We need to see that you are aware that when the air in the table tennis ball get heated up, the molecules in it will move faster, and as a result, both the collision frequency and the collision force, remember, is between the air molecule and the wall, not between air molecules themselves. Okay, it's with the wall because we are talking about pressure. Pressure acts on the surface. So because of the faster movement, the collision frequency and the force will rise. And because of this formula, your F will increase, A stays constant, so pressure in the ball rises, and because the pressure in the ball is larger than the pressure outside, as a result, the air in the ball will expand and it will push the dent out. So if we see that you have this concept in mind, we'll give you the first 1 mark, and then as long as I see any 2 of these points, every 2 points will give you 1 mark. So it is 1 mark per 2 of these points. Yeah? Points, I mean 1 point, 2 point, 3 point, 4 point. Okay, so if you all 4 points, you get 2 marks. So for question 8, I just want to highlight there are many of you who are wasting your time telling me how the heat actually get conducted to the cup, and from the base of the cup get conducted to the top of the cup, which is not necessary. Okay, then there are common mistakes as well. The common mistakes are like you all use the word water molecule become denser. Molecule has no density, water does. Or for example, you say that the water molecule gain heat and become hotter. Molecule doesn't have temperature, it cannot become hotter, but water can. So here I expect some keywords for set 4. I think for lower set, you have been trained very well in terms of this. You all are very okay. But actually we want to see the word bulk movement and the word circulation. So for this time round, we are not deducting mark if the word bulk movement and circulation are missing. We give you chance to learn. But in set 4, when you are giving the exam, you will be marked wrong if the keyword bulk movement and the keyword circulations are missing. So you need to include that last point if you want to score. Okay, for the last question of this video, it will be question 8b. So for question 8b, most of you got it wrong because of part 1. Many of you didn't know that initial rate actually refers to time equals to 0. So when you have a curve, so down here, I'm not sure you can see it, the curve is over here. So when you need to find the gradient of a curve at time equals to 0, you need to first draw the tangent. So how to draw a tangent? You need to place a ruler such that it only touches the curve at 1 point. So here if you draw the tangent, you will be actually able to actually get this line. So this line is what we call the tangent at t equals to 0. And if you find the gradient of this tangent, it will tell you the rate of temperature change at time equals to 0. So this is the way to do it properly. Okay, in set 4, when you are doing practical and you've got a curve, they may actually ask you to find gradient at a point, right? And gradient at a point basically are telling you that, hey, can you draw the tangent? And if you are able to draw the tangent, can you please find the gradient of this tangent? Okay, so with this context, you'll be able to solve part 2. Now for part 2, most of actually we also go easy on you. That's why I write here. We didn't actually play around with the unit and cause you trouble, right? So here you are asked to actually find the energy supply to the water per minute. And many of you who got it wrong, you got it wrong because you take the change in temperature. You actually look at the graph and you tell me that, oh, the temperature change is around 65 and it changes from 20. So a lot of you gave this answer 65 to 20. Now unfortunately, because this is a curve and you can see that at some point the temperature actually stabilized at 65 even before boiling point. So this is not due to boiling. It is being plateaued here. The temperature become constant. It is because now the rate of heat gain from the burner is actually equals to the rate of heat loss to your surrounding. So it is like your father gave you $10 and your mother decided to take the $10 out from your wallet. So effectively you didn't gain any money, so you didn't get any richer. So because the amount of heat given by the Bunsen burner is equals to the amount of heat lost to the surrounding. So effectively the temperature doesn't rise. Okay, and because of this heat loss to the surrounding, you cannot now say that, oh, my temperature change is 65 to 20, right? Because it is not a constant supply. So because of that, you cannot use temperature change equals to 65 to 20 degrees Celsius, simply because once the temperature is higher than the surrounding, heat loss heat is being lost to the surrounding, and so this temperature change is not without heat loss. So how can you find a temperature that doesn't have heat loss? And this is the key concept we want to check whether the student have it in him or her, right? So we know that heat loss happens when there is a temperature change, when there is a temperature difference between the sample and the surrounding. So when will there not be a heat loss? There will not be any there won't be any temperature difference and hence heat loss when time equals to 0, because at time equals to 0 the sample temperature and the surrounding temperature is the same, right? So there's no temperature difference. And actually we know from part 1 that at time equals to 0 the temperature is going to rise at a rate of 4.7 degrees Celsius per minute. So because of that, if you are finding the amount of energy supplied to water per minute, then you can actually sub in the amount of temperature rise per minute, and this Q that you find will be the amount of energy supplied to water per minute, right? For the last part, you were asked to actually sketch out when there's a lead. So when there's a lead to the container, actually what happens is that the rate of heat loss will slow down. And when the rate of heat loss slow down, this means that your temperature rise will increase, right? So there is this number 1 effect, and number 2 is that, remember just now at the very beginning of this question, I say that you are getting the temperature to plateau at 65 because the rate of heat gain from the burner is equals to the rate of heat loss to surrounding. However, now that you have a lead, what will happen? This rate of heat loss will slow down. So because of this drop in the rate of heat loss, you are going to get a maximum temperature that is slightly higher. So because of that, you know that the rate of heat gain is higher, so you will get a more steep curve. At the same time, this curve is going to plateau at a temperature that is slightly higher. So in my answer key, I would expect to see a higher max temperature, and I also would want to see that the gradient become steeper. Okay, so I hope you understand this question now and you won't make the same mistake in your upper set. If you have other further questions, please reach out to your teacher, like and subscribe the video so that I can upload more to YouTube.